Hello everyone, welcome to my YouTube channel. Today I'm solving Leetcode question 114. Flatten binary tree to linked list. Given the root of a binary tree, flatten the tree into a linked list, quotation mark. The linked list should use the same tree node class, where the right child pointer points to the next node in the list, and the left child pointer is always null. The linked list should be in the same order as pre-order traversal of the binary tree. Let's take a look at example 1. The root node is node 1, so the output of this binary tree should be 1, and then followed by node 2, because 2 is 1's left child, and then followed by node 3, because 3 is node 2's left child, and then 3 is a leaf node. It does not have any child node. So in that case, we backtrack and then check the node 4, which is node 3's parent node's right child. So that's 1, 2, 3, 4. And then after that, since 4 is also a leaf node, we go back, check node 5. And then for node 5, it does not have the left child. So the next node is node 6. So the output should be 1, 2, 3, 4, 5, 6, following the pre-order traversal. If the input is empty, so the output should be empty list as well. If the input is a single tree node, the output is also a single tree node as well. I have another video talking about the solution of this problem using a stack. Here I'm going to solve it using recursive method. So the idea is reverse the pre-order traversal. So the linked list following the pre-order traversal. So our idea for a recursive solution is to reverse this pre-order traversal. So the high-level idea is we are trying to store the last visit node in a variable. We call it right child. And then for a given node, we change its left child to none and right child to the last visit node, which is stored in our variable right_child. So the base case is we go down to the very last node in this linked list. So in this example, we first go to the node 6. And then when we go to the node 6, the last visit node is actually none, initialized to none. And then for this node 6, we change the left child to none and the right child to the last visit node, which is none in this case. And then after that, we update the last visit node to this node. And then we visit the next node, which is node 5. When we visit node 5, we change the left child to none and the right child to the last visit node, which is node 6. That's how we construct the output linked list by reversing the pre-order traversal. So we start from the very last node. So now let's code our solution. So we got the root node. So we first check the edge case. If not root, then we just return root. And then after that, if the root node is not none, we have the left child and then the right child as well. So basically, we want to call the self.flatten. We are using this as a recursive function. We call it on the right child. And then after that, we call it on the left child. So why we call the right child first? Because we are reversing the pre-order traversal. So instead going to the left child, as how it is done in the pre-order traversal, we first go to the right child. And then we can assign the last visit node. So in that case, we need to define the child node. So let's define it in initialization self, and then we define self.write child equals none. So we initialize this write underscore child to none and use it to store the last visit node. So in that case, basically we need to update root.left equals none, root.write equals self.write child, and then after that we update the self.write child equals root, and then after that we return. So let's run the solution. Let's submit it. It's an accepted solution. So the idea is, okay, so we first check the edge cases, and then after that we call the recursive function on the right child and then left child because we are reversing the pre-order traversal. And then after that, for each cases, when we return, so we just before we return, we just set the left child to none and the right child to the last visit node, and then we update the last visit node to the current node before we return. So let's take a look at the code execution through an example. So we are using the example 1. So at the very beginning, we call the function on the root node, which is node 1. And for that, we first call it and then after that, we call the recursive function for the right child, that's node 5. And then when we call it for node 5, we continue calling the recursive function. We call it on node 5's right child, which is node 6. And then for node 6, it's a lift node, so both functions return none because node 6 is a lift node, and then it does not have a left child or right child. So both of the self.flatten return none. And then after that, we assign. So basically, we assign the last visit node, which is none in our case because this right underscore child variable was initialized to none. We assign that to node 6 right child, and then we set the node 6 left child to none. And then we assign node 6 to the right child. So now our right child becomes node 6. So that's our last visited node. And then we finish visiting node 5's right child. And next we check node 5's left child. That's none. It's just return none. And then after that, after we check both node 5's right child and left child, we assign the last visit node self.write underscore child to node 5's right child. So remember, the last visit node here is node 6. We assign node 6 to node 5's right child, and then we set node 5's left child to none. So in that case, we construct this part. So from the very bottom, node 6, and then we assign node 6 to node 5's right child. And then after that, we update, so the last visit node becomes node 5. And now we are visiting, we call it self.flatten for node 2, because node 2 is node 1's left child. And then similarly, We can also write down the execution process, similar to how we check the node 5 and node 6 for the node 3, 4, and 2.